Okay, my next victim here is a Motorola 57X2 that I picked up at a antique store. It's a really neat white plastic case, and it's kind of dirty, filthy, but should be pretty interesting. Looks like a standard All-American 5. I've never taken it apart yet. 50C5, 35W4 rectifier, 12CR6, that's kind of a new one for me, 12BA6 and a 12BE6, I'm used to those. So should be an interesting little thing, and we'll have to take a look at it and see what it looks like. Never like to plug any of these things in until I get them apart and look at them, because who knows what's wrong with it. So let's take it apart and see what happens. I think before we get any further here, I'm going to wipe this thing off a little bit. We'll give it a good cleaning here when we're done, but at least that'll keep me from getting my hands all filthy. Okay. I think this is going to clean up really nice. Okay. It's pretty nice. Got a removable antenna. Tiny little chassis. It looks like this could even handle 2 speakers. There must be a 2-speaker model as well. Pretty cool. Okay. Well, let's take it on apart and see what's inside. Well, here we go. Looks fairly simple. Has some crud on here, some corrosion, but not bad. All cleanable stuff. Let's look underneath. All original. And these sealed capacitors, I don't know. Sometimes they work, sometimes they don't. Definitely got to get rid of the bumblebee. That may cause problems. Looks pretty simple here. So, very good. I guess the next thing to do is go online and see if we can find some documentation on this, although we could probably figure this one out without it. Just be interesting to see. So, I'm going to go up and do a little search on this and see if we can find some documentation. Okay, after some difficulty, found a print out there, and we're going to see, first thing we're going to do is maybe clean this up a little bit. So I'm going to clean off some of these, get some of this white nastiness off of here, and come back and see what happens. Well, I've got good news, and as you can see, I've got bad news. The good news is the chassis is all cleaned up. I found documentation. The bad news is this was sitting there while I was cleaning the chassis. It rolled off and it crashed on the floor. And this is, of course, as Murphy's Law would have it, the 12CR6, which is the oddball tube that I do not have another one of. So, looks like we'll have to order a replacement. Hopefully I can find one for a reasonable price. And obviously this project won't be finished soon, or at least until we get another tube. So anyhow, we'll flip this over, and I guess we'll continue with some of the component changeouts. Okay, let's go through and look at some of these resistors here. First one here looks like a 470K. See what we get. little bit high. 20% though, so that's probably acceptable. Alright, let's go over and do this section. This one here looks like a 2.2 meg. Yeah, a little bit high. A lot of times those ones don't make a huge difference. Another 2.2 meg down here. That one's a little higher. That's climbing up there, so maybe change those out, even though a lot of times those don't matter, because those are, if you look on the tube that I broke, that would be pin, let's see, looks like they're using 2.2 meg. Looks like they have one of them going to one of the coils, and again that one probably isn't going to make a big difference. And the other 2.2 meg, where are you? You probably see it before me. Okay, right there, 2.2 meg. Come off the volume. It's AVC. I think that's part of the AVC circuit. I don't think those are going to make a huge difference. Alright, 150 ohm. 163. Another 470K. Alrighty then. Looks like we have, there we go, 487. Okay. Must have just had some crud. 470K here. That's a little bit low. We might be reading across something. Usually when you're looking at these resistors, if they read lower than their normal resistance, that's usually you're reading across something. It's when they read higher than the resistance that you really want to look at it carefully. This one here looks to be a 10K, 100K, sorry, 100K. Brown, black, yellow. That's high. That one's going to need to go for sure. 131K. And this big power resistor is, looks like a 390 ohm. 400, not too bad. Another 390 down here. Wow, 394, beautiful. And last but not least, there's a little one hiding down in here, which is a 15 ohm, believe it or not. That's high, 25 ohm. That one's climbed up there, so that one we may want to do something with. Not a big deal. We could check it and see if we still have our 114. We have 114 volts right here, supposed to be 90 volts on this side. Here's your 15 ohm resistor coming straight off. I think that's just kind of for current limiting and so forth. That may be okay. But 25, if I have one, I'll replace it. Because really this is a time waster project. And one last little hiding one down here. What do we got? 22K by the looks of it. Let's see what it says. 27K. So That's a little bit high, although it is plus or minus 20% again. 20% is an awful lot, so with the exception of this 100K, that was the one that I think was bad. Yeah, so that one's definitely got to go. Hopefully I've got some resistors with these really long leads on here. I'd love to replace it the correct way. As far as these caps are concerned, these ones look better because they seal up, but they actually will crack open and leak out the sides because of these tubes the way they're built. They may be good. Maybe we'll check some of them out and see what they look like. First thing we'll try is the little capacitor checker built into this meter. We also have our ICO 950 and we have our Sencor LC53, and we have our little ESR checker, which isn't really good for little caps like this, but they're more for electrolytics. Alright, 51 nanofarads. And that's coming off the volume pot, which if we go over here, we have, these are all, looks like, where's the tap? Okay, I see this tap here. This is coming off the one leg, and it goes to this. So that's going to be not the center tap one. Looks like this is something else here. This goes on to pin. Let's look. Looks like this is pin 1 right here. This one is not being used for anything but a tie point. It actually is not. Oh no, this is a tie point right here, which would be the 2.2 meg going to the tie point of the other 2.2 meg. So that would be right here. And somewhere we should be seeing, yeah, there it is, this little wire. Turn this over. This little wire right here goes over to here. Ties all these guys together right here. Okay, so this would be pin 6, it looks like. Pin 6, that'd be a 0.05, which would be 50 nanofarads, and sure enough, 51. That one's still good. Of course, we didn't do a leakage check, but preliminary. 0.006. What an odd capacitance. That one's out to lunch. That's reading 0.009. Let's see what this one is. Another 0.006. Whoa. Wow. Yep. You always have to recap these things. This one here, which is a 0.00. No. This one should be another 0.05. Yep, 0.05. That's not too far off. 5.6. A big old 0.1. And it's 0.2, so that means it's probably a little bit leaky because it's double what it should be. We have this electrolytic, which is, let's see, where's our ground, is right here. here's the one leg. Wow, 163 microfarad. I can pretty much tell you that's not 163 microfarad. Actually, it's supposed to be a 30 microfarad. There's two 30s and a 40 in there. Somehow, I don't think this cap is any good. Oh yeah, they're all reading high. To be expected. So, with that in mind, we've got all the caps to replace. I'm not going to play around. We're just going to replace them. Now, I'm not sure about these .006s. That's an oddball size. And I'm not sure if I change that, if that's going to make a big difference. I might have, nope, I have a point. Let me see, do I have .0047s and a .0022 and a .001, so I could probably stack up an 0047 and an 001 and get 0057, which would be pretty darn close. But maybe we'll do that. There's only two of those in there. The rest of them, I think, I got some ceramics, and of course those are always good. They don't go bad. And then we have the across the line cap, which is that Fumble Bomb. And it looks like, no, that one's the one that goes to ground. That's the .1. And the .047, where's he at? .047. I'm not seeing it. Oh, maybe this. Yeah, that goes to ground. Oh, no, it doesn't. That is the .047. And the .1 looking like it's, that has to be the .1 right there. That one's going to chassis. That's actually the one that's taking your chassis to your ground. That's your isolation between your chassis and your ground. And it's leaky, which is a bad thing. So we're going to pull all this stuff out and start replacing it. So let's see. Okay, I did find a nice 15 ohm flame-proof 1 watt resistor, and I had to take this red wire off from the original capacitor because it doesn't reach over here, so I have to put a longer piece of wire in there. So I'm cleaning this off. I thought I'd share with you a couple things how I clean these terminals off. First of all, I'm not one of those people, I don't really care for clipping off the leads and then twisting them, the new ones around. I kind of like to do a little neater job than that and try to make it look like, not original, but at least professional. So I'm using solder wick here. Now on these little tabs, sometimes this is the best way to go, especially if you have a hot enough iron that can get in there pretty quick. As you can see, it cleans it off pretty good. Get that cleaned out. See if we can zoom it in a little bit. Let's move this out of the way. A little bit. Get in here nice and tight. And maybe we can see what we're doing here. Actually, I'm going to move this so that I can work a little better. Okay. How's that? Much better. Okay. So, let me get down in here. clean this off a little bit. I'm not going to show you all of these that I do, but give you an idea, kind of my method of doing this. I guess everybody has their own way they like to clean these off. And I just like to get some pliers with some serrated tips in them and just kind of open it up just like that. I can snip this off right here. Out of there, and then hopefully get this right out. And this side here I've cleaned off already somewhat. See if it's ready to come loose. Maybe not. Might have to heat that up a little bit. Moving. There we go. Just come right in here. Trim it. And then clean. Don't let those little pieces of wire fall in there. You'll forget about them, and next thing you know, they'll be shortened between some pins of your tube. There we go. Get rid of that. Should be ready to come right out. Okay, so we need a wire on this one and the resistor, and then the other end of the resistor on this one. So now all we need is the resistor. Where did you go? Right here. Okay. So, take this, and I don't go real crazy wrapping these wires around because that just makes it harder to work on in the future. I kind of like go. Solder this first one on here. There we go. Out. Really? Did you guys see what I just did? I'm watching the camera and I'm not watching you guys, and I trimmed my resistor off. You saw it, folks. Are you guys sure you want to be watching these videos? Okay, let's try this again. I'm not going to edit this out. I deserve to be publicly humiliated for doing such a thing. Alright, here we go. One more once, as they say. Making an awful long video here, guys, for a time waster radio. If you're all bored, I understand if you fast forward. Just so you guys know, I'm having fun. Are you having fun watching this? I hope. Alright. Now, the idea is to clip the lead without clipping everything else. Like that. Okay. Alright. Now we need a piece of wire. And let's get something trimmed up here. Try to get this through here, which is always fun. Hey, look at that first try. Okay. Get this in here. That's it. Alright. Let's see if we can redeem ourselves by cutting this one properly. There's one. And two. Very good. Alright. We go. Heat 'em up. Okay. And we'll put this over here. Isn't this exciting? All right. So the red needs to be a 40 microfarad, and the other two need to be 30s, and what I have is 33s and 47s, so that's what we're going to get. So let's see. We're going to put this third one right here. See if it'll go across here. For some reason they ran this over, so I'm going to do the same. Probably because they don't want the noise, although there shouldn't be any. Do we have enough length? I'm not too crazy over that. Let's get another piece of wire. I don't think I have an orange piece of wire, but I do have a yellow piece. Okay. So we're going to clean this one off. And I think this one we're going to do with one of these. And we'll be right back.
Hey you.
Okay, here's a little update on where we are now. Got most of this chassis all cleaned up. Got this working really well. Nice and clean. Nice and lubricated. And on the underside, get this turned around here, got all the capacitors replaced. The other thing you might notice I did is I changed the power cord, and I had to change the configuration. I don't know why they did it, but all of these series strung transformerless AA5 radios have the same situation, and that is, if you look on the schematic here, they come in with the power cord, and one lead goes directly to ground, and the ground is the one that always gets switched. Now, I don't know why they do that, but apparently that's just the way they do it. I could put a polarized plug in, which I did, and leave it like this. The only problem is, if you shut off the neutral, you still have the hot all the way up in here. So if something did short out, theoretically you could still have problems. So you could still make something be hot if you touch it and you touch something that's grounded. So what I did was I switched these around. I took this switch and I moved it over to here, the hot line, and I took the neutral line and tied it directly to the ground or to the neutral side. So if you look here, that's what we did. We disconnected down here, ran my hot directly here, ran another line out of there and into the rectifier tube. Okay, same as the schematic. The neutral comes up here onto this strip that I added on, a little terminal strip underneath if you can see it. And I moved all of my neutral connections over to there. The other thing I did was get rid of this bumblebee capacitor. These are what they commonly use for your across the line capacitor. They're not safe. They can blow up, they can burn out, they can short. I ended up putting a safety cap. Safety caps, in case you don't know, they're designed in such a way that if they short out, they won't catch on fire. They're what they call a self-healing capacitor. So what that means is if something does short out in here, it's going to stay internal to the capacitor, and it's not going to allow something to catch fire or to burn or so forth. So it's a much safer setup. So now this should be a relatively safe radio to operate. You still never want to service one of these without using a line isolation transformer. What that does is that isolates your actual hot and neutral and so forth from your main ground in your house system. That way, if you do get a hold of a cold water pipe or something that's grounded or something like that, and you touch this chassis and then by accident it's hot, you're not going to get shocked. Hopefully, you're not going to get lot less chance of getting electrocuted. Changed out the electrolytic capacitors, 3 of them, and this radio is about ready to go. And if it weren't for the fact that I dropped that daggone 12 CR6 tube, which belongs right here, as you can see, we'd be ready to turn this thing on and see if it works. So I guess we're going to have to come back as soon as the tube comes in. I did order a replacement. We'll get the tube put in, we'll come back, and then we'll start working on the alignment and seeing how we can get this thing to line up and see how well it performs. Okay, I'm back, and as you can see, finally got a new 12 CR6 in a couple days later. Hopefully I won't drop this one and break it as well. Anyways, we're all cleaned up. Got everything neatly put together here. I think we're in good shape. And I did move the neutral side over to the ground, and I made the switch the hot circuit on and off instead of the neutral. So I think we're ready to do some power up here. So let's get some speakers and antenna hooked up and see what we get. Okay, here goes nothing. Let's turn on the Variac. We're going to start out with about 25-30 volts here, and we're not drawing any current at all, hardly, very little. Give it a minute here. And we're going to take it up a little higher, up to about half power here. So far everything's good. More. Should be hearing something here pretty soon. Oh. Yep, getting something.
for law enforcement. Chelsea was on the phone. Oh, I've got to go. Turn. Prince.
Well, I'm getting something. I think we need an alignment, but not bad for a first power-up.
In this country until absolutely crazy. And no other country recognizes this. Oh, look, you know, I happen to be in this country, and, you know, I had a baby, and now there's...
Well, let's set up some test equipment here and see what we get. I think we're going to try a different piece of test equipment today. Instead of the old-fashioned RF generator, got something over here that might be some fun to play with a little bit here. If we can zoom in a little bit. Got an old Sencor SG 165, and really great piece of test equipment for radio. So I think what we'll do is we'll start out with our 455 kilohertz IF, and we'll connect this in and hook it up to a to the dummy load. I'll show you that here, because rather than blasting the speaker real loud, we should be able to hook it over here to our dummy load resistors, and then we'll monitor it with this little jewel here, my RCA Master Voltomeist, and we'll go old school. So let's get everything hooked up and we'll see what we get. By the looks of this, what we're going to do is very simple instructions, but basically we have our antenna and our oscillator on the tuning capacitor, and then we have basically two cans here. We have first IF, second IF, and you can see the order they want you to tune them, and 455 kc. So it should be relatively simple. So let's get hooked up and we'll go from there. Alright, a little addendum here while I was getting out test equipment. I've noticed these two tubes are getting entirely too hot. I don't see anything red plating yet or anything, but man, oh days are they hot. So we're going to get underneath and check some voltages and kind of back up a little bit here before we go any further with our alignments. So be back in a second. Okay, so our first connection here that we're looking at, we're looking right here, and they're saying 114 volts we should be getting. So watching it power up now, see what we get. So far it's under 114, but it doesn't look like it's slowing down too much. Yeah, there it goes. Okay. So I'm at full power right now. According to this, I'm only getting 111, 110. So that's very close to 114. So let's move to our next one, which is the next line over here. We should be able to get, looks like we're dropping it in 2 stages, so let's see what we get with our 90 volts here. If I can find somewhere, here we go. That's 100, and on the other side of this resistor should be 90. I think that's 90 volts. Wow. So my next question is, why are we getting such horrible heat, especially out of this 50C5? So the next thing we want to look at is pin 6 of the 50C5, which is our screen grid, and see what it's doing. Pin 6. Let's see here. That's where I am, is pin 6. According to this, pin 6 should be 95 volts. It's 92, so it's good. And pin 1, right here. Pin 1, we want 6.2. That's a little bit hot. As you can see right here, let's see if we can get it to focus. Right here, pin 1, 6.2 volts. I'm getting 8.2 volts, so that's a little bit hot. Pin 7, we would like to see 111 volts right up here. That's on our plate, and we're getting a little bit low, but nothing out of the ordinary. So, and not sure what our 150 ohm and our 470K, we probably should measure those. So we got these 150 and our 470K. Those are kind of going to set your bias for that tube and make sure we're not drawing too much current. Being that there's 8 volts on there instead of 6.2, we're drawing excessive current, which definitely could be causing that problem. So let's power down, and I think our next thing is we need to check this right here, 150 ohm resistor. I don't know if you can see it, but it is right here. I'll try not to electrocute myself while this is discharging. So, and the 470K is right here. We'll measure that as well. So let's move over from ohms to volts, or volts to ohms, and we'll just do a static in-circuit test. We know that it has to be 150 or lower if it's in circuit. And okay, our 150 is a little bit high, so that might have something to do with it. So it's 166. So and that is actually a 10% resistor, so you're right on the edge of that 10%, but I still think that's too high. The other one is going to be the one that goes to the same place. That would be from here to here. Is our 400. Here's a 470K, and it's 478. So that one's good, and it's a 20. That's a 20%. It's not even a 10% resistor, and I'm 470. I'm reading 479 for something that old. That's very good. And just for the heck of it, even though it really shouldn't have to do anything with that, we have this other 470 right here. We can measure that, but that really isn't going to make a whole difference. You're isolated by this 0.01, so I don't see anything wrong with that at all. So I think the biggest one we got to go after is this 150 ohm. So let's take that out and let's replace it with a good 150 ohm. Let's see if I've got one to begin with. Let's see. 150, there they are. We even have a couple loose ones out here, so let's take one of these out. Alright, a little bit of a rant. How much do you think it cost to put an extra ½ inch of wire on each side of these? I've noticed these newer resistors actually have shorter wires on them. Now that's great for through-hole PC boards, which I'm sure that's what they're expecting you to use on it, but if you notice, all these older resistors have much longer leads, and of course they take advantage of that by making them span very long distances. And as you can see, I'm probably going to be a little bit tight. I'm not going to have enough wire on this, so I'm going to have to do one of the things that I really hate, and that is to tack my leads onto part of the existing leads of the other resistor, and I hate that, but at this point in the game I don't really know what else to do. So let's change out the resistor and come right back. Okay, check this out. Almost as if it were made for it. There was a hole already drilled right here, you can see, and so all I had to do was put one of these single terminal strips. It's like it was made for it. Now I didn't have to kind of bodge on any wires there, and I got my new 150 ohm resistor. Now that I'm done heating it and so forth, let's just check real quick, see what our resistance is. Whoop. And 148.02, pretty close. Better than 166. So let's see if that does us any good. So we'll get all set back up and check our voltage. See what we get. Okay, power on. And see. Yep, tubes are lit. Alright, let them heat up, and hopefully we'll get closer to our 6.2 volts. Remember, we were at 8 point something. I think that was just too much current. She's slowing down. I think that's looking better. Much better. Okay. And I'm not getting that crazy hum now either. Jumping around a little bit, but tubes do that. Definitely not at an 8 volt range. We're staying between 6 and 6.4. We're jumping. Uh-oh, there we go. That's not good. Let's see how long it stays. You know, I wonder if maybe I don't have a tube going bad. Yeah. I think I got a bad 50C5 also. I cleaned the sockets and I put some deoxit into them, but I think I got a bad tube. Oh yeah. You hear that? I don't know if you can hear that. That's coming through the speaker. That's not the glass from me tapping it. And that's raising the voltage. So let's pop in another 50C5 and see what happens. See if that makes a difference. Okay, I got a new 50C5, and let's just see what happens. It's not new, by the way, it's just another 50C5, but it's a good one, and hopefully it'll give us better results. I also noticed this one's already heating up coming up much faster than that other one did. That other one seemed to be really slow coming up. Let's see if we get our 6.3. I don't hear any of that hissy scratchiness either, and looks to be settling a little bit. Oh yeah, much quieter. I think we had a bad tube. We had a bad tube. This one's hot, but not like ripping your hand off hot. You're not leaving skin on the tube housing. Okay. Well, let's go back to where we were now. I think we're going to be okay. And let's try connecting up our signal generator, our SG165, and see what we get. Okay, we're connected up. And we're going to go right into the converter tube. And we're going to see where we are here. Let's move our camera over here to the meter. And see if we can get it to come in here. would say that is peaked out. Okay, now let's switch over to RF. Let's disconnect this from the converter tube. Let's make ourselves up a loop. Let me go back down here. And the next thing we're going to do is take one of these little loops here, and we're going to connect our antenna. Very important when you do the oscillator and the antenna alignments that you use the actual antenna that comes with the radio. That's very important because it definitely affects that circuit. So let's move this. I probably shouldn't be doing this while it's turned on and live, but you know, I guess that's the way it is. Here we go. Okay. Now, the other thing, probably it should be mounted in the box. Let's just unplug this and get things situated. When we get set up, I'll come right back. Okay, we have our SG-165 now connected, and we've loosely coupled it through this little coil and laid it across the antenna. I'm tuned up towards the top of the scale, which is right up in our 1620 range, which is maximum. Okay, so we're wide open. And let me get this here so you can see. On the SG-165, what I've done is I've switched over to the AM RF, and I've adjusted my RF tuning up to 1620. And what we're going to do is we're going to get this set up, and we're going to peak it out. I have this set so that I hear static on my output. I want to hear static because I don't want the AVC acting, so you kind of turn it up so you can hear a clear modulated tone, but you still hear the static in the background. That kind of tells you that you're not overdriving the input and you're not activating the AVC. The auto voltage control is not something, you don't want that interfering with this. You want it to be not influencing what we're doing. So by turning everything down, we're kind of taking that out of the picture. So the first thing we're going to do, get some volume here, and you can see turn it down some. Alright. Get some static. And I can tell right now this is pretty close. But we're going to go ahead and just tweak it a little bit, see what happens. Let me get a different stick. Folks, don't try this at home. Okay, and now I got it loosened up a little bit. Let's see if we can. Use the screwdriver. There it is. Okay. Now our next thing we're going to do is we're going to do our antenna adjustment. And for that you really should have this in the dial scale. What I'm going to do right now is I'm going to take it down to where I think roughly 1400 kilocycles is. I'm going to dial my SG-165 to exactly 1400. And go down one notch. You can see, I think we're off a little bit on that. So I'm going to adjust it. We're going to put it back in the case. If I'm off, then I'll take this back apart. I'll make that one last final adjustment. Okay. Yeah, I think we're off a little bit. Still too much. Okay. That's pretty much it. So we did our first IF, our second IF, our first IF. We went in and we did our oscillator, and then we did the antenna trimmer. So technically this should be aligned. So let's get it into the case, get it into the real world, and turn it on to see what we got. And maybe if we have to readjust that antenna, if you notice there's a hole right here just to do that. So let's see what we get. Just wanted to show you before I put this thing all together how clean this radio is. Now I did clean it up. There was dust and dirt in it. But isn't this amazing for how old it is? Beautiful, beautiful condition. You never ever see a radio in this kind of shape that's this old. Not a crack, not a scratch, nothing. Just thought I'd share that with you before I got everything put back together. Okay.
Apologize for winning anymore.
All right.
See, that's cool.
Here we are.
That's different than this. So incumbent you might understand and know. The leadership by legislators and Washington forces us to win. Towards the end of the presented by Rutgers University and True Total Media and
very good. Now I'm in the basement. I live at the bottom of a hill. We're in about as bad of a place as you can be, and it's a stormy night. And we're pulling in quite a few things.
And the top shows.
The orthopedic care can cost less. From sports medicine and arthritis treatment to joint.
Well, that's a wrap. I think this one's ready to be put up. It's in good shape. Well, thank you very much, and comments are always welcome. And I hope you enjoyed this. I know it's kind of a long video. Let me know. I'm kind of new to this thing, so let me know what you think. And too long, too short, not enough information, too much information, let me know. Have a great day, and thank you.